Alright, so here's a review of 1, 2, and 3 from page 121. This is part of your classwork on day 19. So, we're pretty good at figuring out the resultant when we have a 90-degree angle. But sometimes we don't. Sometimes we have a different angle. And for that, we have to use a special formula. It's the law of cosines. It looks like this. R squared equals A squared plus B squared. But now we have to add in a correction because the angle isn't 90 degrees. So that correction looks like this. Minus 2 times A times B times the cosine of theta. And the theta being the angle between those two legs. Not any other angle, but just the angle in between those two legs. So, it's pretty simple. Take the formula, plug in, square root it, just like you would with the Pythagorean theorem. So, let's take a look at how that works. For problem number 1, you've got a car going west, then south. Due west, due south. So 90 degrees or other than 90 degrees. Basically, are we going to use Pythagorean or are we going to use the law of cosines? Well, these are 90 degrees from each other. So we're just going to use the Pythagorean theorem. It's going to look like this. Number 2, we're going to walk 250 meters down a line of cars and then turn 90 degrees. So again, that's a right angle. So another setup like this. And looks like that for the solution. Okay. All right. Next. The next one's a little bit more tricky. It's not equal to 90 degrees, so now we have to use the law of cosines. These are the numbers you plug in, and that should be your answer. All right. So that's 1, 2, and 3. There. Let's see. After that, copy this example and take a look at it. This is a good word problem where we do not have a 90-degree angle. And so we have to use, again, the law of cosines. We have to break, we're going to use the law of cosines. We have to break the vectors into their components. All right, so following these steps here, and then add together the x components, add together the y components, and then use the Pythagorean theorem to figure out the vector, and then use the inverse tangent to figure out the angle. So, with that, some practice problems for you to do. I'll post up some answers to these later, and then these ones are going to be some more practice for you to do in class, and then some more practice for homework. And that's it.